Joshua Jampool here. Our stage is set, the launcher ready to go, liftoff due in just a quarter of an hour, the 9th of the year for Ariane Space. Our launch today for the European condition under a contract with the European Space Agency, and we'll be hearing now from John Werner, Director General of ESA.
Dear representatives of the European Commission, ladies and gentlemen, welcome to Kourou, the European Spaceport. Unfortunately, I cannot be with you today. But I'm witnessing this very important event, the first launch of Galileo satellites with an Ariane 5. 4 satellites in one launch, this is a premiere for us. Galileo is of course a flagship program for the European Commission.
A look at the launch with Ariane Space's Thierry Faem.
This launch will be performed with an Ariane 5 ES version, already used for ATV missions. This launcher is composed in particular of an EPS upper stage, which is different from the commercial Ariane 5 ECA version. The EPS storable propellant upper stage is powered by a reignitable engine that operates with MMH and N204 propellants, allowing reignition capabilities essential for required Galileo mission performance. A specific dispenser has been designed by Airbus Defence and Space, allowing to support a satellite maximal mass of 738 kg each. This dispenser is made from a combination of metal and composite materials for maximum stiffness, and it has undergone very comprehensive testing at Airbus Defence and Space premises located near Bordeaux.
The Galileo program, funded by the European Union, it's a new global satellite navigation system which will guarantee European independence in this area, and Ariane Space very proud to play a part. As is so often the case with Ariane Space, there's something new with this launch, several things, in fact. Those of you familiar with the Galileo program know we usually launch with a Soyuz. Well, as you can see, Soyuz has been replaced by Ariane 5, taking that role. And if you've been following the Galileo program, you will also recall that we launch in pairs, that is 2 per launch. And you've also noticed that we're launching not 2 but 4 satellites on the mission today. With Ariane 5, we can lift about 7 times the weight that Soyuz can, so we're taking full advantage of that power. And of course, since it's the first time we're launching 4 Galileos, design a new talk about that later on. For the moment, take a look at a short film on the launcher campaign.
As usual, after an 11-day trip via the Atlantic Ocean, the Ariane 5 launch vehicle elements arrived by ship in Kourou, Pariacabo Harbor.
The launch vehicle preparation campaign, like all the other ones, began by the unloading of the first stage, the EPC, the cryogenic central core. Next step is to transfer the solid rocket boosters, the EAP, from the storage building to the preparation building. After integration on the launch table, the main core is mated to the boosters. Till that point, the operations are the same as for the other Ariane 5 versions. The main characteristic of this Ariane 5 ES Galileo launcher is in the upper part before integrating the payload. This upper part is equipped with a vehicle equipment bay that is integrated directly into the EPC. The storable propellant stage is directly integrated into the VEB. The fueling is conducted in the final assembly building, where the VEB is first filled with hydrazine. Then the EPS is filled with MMH and N204 before final pressurization of the helium spheres at 400 bar. On the pneumatic and fluid side, the EPS and the VEB are ready to enter the automatic sequence.
The satellites campaign began early September with the arrival of the 4 spacecraft by cargo plane at Félix Éboué Airport. After transferal of the satellites to the European spaceport, the first operation was the fit check between the satellite and the dispenser. This is to verify the mechanical compatibility between the spacecraft and the launcher. Everything went well. We continued with the preparation of the spacecraft in the S-1B clean room. The satellites were then transferred to the S-3B fueling building, and we filled the 4 satellites. After filling, the satellites were integrated onto the dispenser to give what we call the stack. And the stack was then transferred to the final assembly building. It was integrated onto the launcher, and after the final inspection of the upper part, the full fairing was connected to the launch vehicle. On Tuesday, November 15, the launch vehicle, fully assembled, was rolled out from the final assembly building to the launch pad, and the final countdown operations began.
We are lifting 3.2 tons tonight with the 4 satellites and the new dispenser, which carries and separates them. That weighs over 400 kilos. The heavy lift Ariane 5 can orbit much more, you'll recall. It's the only commercial launcher on the market capable of lifting 20 tons. And the last time we used this version, it was for the 20-ton ATV, the Automated Transfer Vehicle, which took cargo to the International Space Station. That was 2 years ago. Many key people in mission control here, one of them the mission director you just saw, Thierry Villemar from Arianespace, working with Myrto Madelon, who is the Range Operations Manager, also called the DDO. It's his first mission in the role tonight. DDO from CNES, the French Space Agency, and he makes all the key announcements on the major milestones during...
À tous de DDO. Attention pour la séquence finale lanceur.
And during the countdown and during flight, and it's his voice you'll be hearing.
Top, H0 moins 7 minutes.
As he announces the 7-minute mark, which is a key moment in the countdown. The synchronized sequence, it's called, a complex series of operation running right down to liftoff, letting the launcher become autonomous, power passing from the ground, which controls everything now, to the 2 onboard computers, which will control everything afterward. The green status panels on the right of your screen are a summary of all the launch activities here at the base. We go when the satellites, the launcher, and the base are ready, and ready means green, and you see all is green now, so we're right where we should be. The green status panels include the launch system, which is a launcher and the pad, the range itself and all the services provided like telemetry, radar, safety, weather, the ground facilities, and all the rest. Over to Alexis Macaire of Arianespace now for a brief description of the mission today.
So we are located here in the station from which we will follow the flight. So the beginning of the flight will be followed by Galileo station here in this station. Then we will use the SNA, which is a boat located in the Atlantic Ocean. Then the Azores Islands, which are located also in the Atlantic Ocean. And then we will use New Nursia, which is located in Australia, to follow the final part of the flight. So this Ariane 5 flight is unusual in a way because we will target an MEO mission. The flight will target a northeast direction in order to reach the inclination of about 55 degrees. The satellites will be placed at an altitude of 24,000 kilometers, which is very close to the operational orbit for the Galileo spacecraft. The first part of the flight is a standard one. The atmospheric flight is performed by the EAP. And then, after the separation of the EAP, we will follow with the EPC flight, during which the fairing is separated. At the end of the EPC flight, which lasts about 10 minutes, we have the ignition of the upper stage, the EPS, for a first boost. So after the cutoff of the first boost of the EPS, we have a long ballistic phase which lasts about 3 hours in order to reach the altitude of the final targeted orbit for the spacecraft, 24,000 kilometers. So after this ballistic phase, we have a reignition of the EPS. We'll perform the second boost in order to reach a circular orbit for the spacecraft. after the second boost of the EPS, we start the final ballistic phase, during which we separate the spacecraft. So we will begin with the first pair of satellites, which will be separated. And after 20 minutes, we will separate the second pair of satellites. And from this event, we will start a passivation phase of the EPS, and that's the end of the mission.
This final 7-minute sequence is just the tip of the iceberg, actually. Final countdown on the launcher began 13 hours ago. At -10 hours, we had a check of all the electrical systems. On the satellite side, the Galileo teams began working 9.5 hours ago. And spacecraft countdown activities began about 40 minutes after that. A lot's still going on because the tanks are going to be pressurized for flight at -4 minutes. That has already happened or is still going on. And then at -1 minute, the launcher will be switched over to onboard power mode. Our cameras are here in Jupiter, but also at other places where people are hard at work today. One of these is the Launch Control Center. It's a very busy place, the launch zone, as you can imagine, where the launch management teams are working under the direction of the Launch Operations Manager, Klaus Zell, tonight. 2 teams are working up there. One is responsible for ground operations, the other for the readiness of the launch vehicle. The Launch Site Operations Manager heads up one group coordinating here with Mission Control in Jupiter for final authorization of the launch. When all conditions are right, he then okays the automatic sequence, which we saw, to begin at the 7-minute mark. In all, about 100 people working up there, going over the final checks and verifications on all parts of Ariane's launch system. They're closer to the pad than we are, too. We're about 15 kilometers away here in Jupiter. They're right up there, 3 kilometers from the launch pad. We've slipped just under the 2-minute mark. Here in Jupiter, the VIPs and the invited guests are making their way outside to watch the liftoff. If you haven't been down here, there are 2 on either side of Jupiter giving a fine view onto the pad. And they are this morning. The visitors will have quite a sight. Here in Jupiter, you can see the operational teams, but in fact, to launch Ariane or Soyuz or Vega, we also need security, we need support from the Army, we need firefighters, journalists, and many, many other professions. The DDO is going to call out the 1-minute mark, and we will be into the final.
À tous de DDO. Attention pour H0 moins 1 minute.
And we'll be into the final 60 seconds.
Top, moins 1 minute.
And there we are, final 60 seconds before liftoff of the Ariane 5 with 4 Galileo satellites. Give us a chance to say hello to our friends at Bremen, at Astrium Safran Launchers, to the Galileo teams, to the Kourou, Sinnemarie, and Cayenne sites here in French Guiana, to all our industrial partners, to everybody at ESA and CNES and all their offices, and to all of you following on the internet. We hope you all enjoy the broadcast. We're going to cut away and let you listen to the DDO as he calls out the final seconds, and we'll be back once Ariane has cleared the tower. Enjoy the liftoff, everybody. Final countdown coming up.
À tous de DDO, attention pour le décompte final. 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage Vulcain. Allumage des EAP, décollage. Les paramètres de propulsion sont tous nominaux. La trajectoire est nominale, tous les paramètres en bord sont normaux.
Darting behind the clouds, in and out, Ariane 5 beginning her mission. Beautiful shots, lifting off at 10:06 local from the ground, roaring off the ground here in French Guiana, beginning her mission, the 9th for Ariane Space this year, carrying the 4 new satellites in the Galileo constellation. Always impressive shots for the people here at Jupiter and on the beaches and at the observation sites, leaving her trail of smoke and fire. The 2 boosters providing 99% of the thrust right now, propelling the launcher along her trajectory at an ever higher velocity. 760 tons was the mass at liftoff. She's burning 5 tons of fuel every second. Yes, that's every second. 2.5 tons burning in each booster per second. Plus the core stage, first stage burning another 300 kilos of fuel per second. Ariane 5 now following the program in the onboard computer, which gives all the orders, including stage separations, which we will soon see. We are in the first of 4 flight phases, and we'll describe each in turn and in detail. So you can follow Ariane as she heads northeast across the Atlantic. Meanwhile, the DDO saying all well on board. Right now, the first flight phase, the single Vulcan core stage engine, and the 2 boosters are burning. The boosters are going to burn for another maybe 10 seconds, not even, and then you'll see them flame out and extinguish. And there they are, and the DDO has confirmed that. That's what it looks like up there. There's the second booster on the left out of camera range. The boosters fall 500 kilometers from shore in a protected area. You can see the shot there. The 2 boosters, if he can hold his camera steady. Well, we have 2 boosters on either side, and the main point of light was the core stage burning. Before the boosters are empty, their push diminishes, and the onboard computer senses the drop in acceleration and decides to separate them. On the bottom of your screen, our altitude on the left and our speed on the right. Altitude approaching 100 kilometers, and our speed 2.5 kilometers per second. Remember, we need to be between 8 and 9 kilometers per second to separate the satellites. We're coming up on separation of the fairing. That's in about 20 seconds from now. You can see in the animation the logo on the fairing that's placed there by the customer. Something of a tradition goes way back in the space business. A lot of people collect stickers and decals. The inside of the fairing lined with acoustic panels that protect the satellites from the noise, and there is a lot of noise, of the engines at liftoff.
Séparation de la coiffe.
And there's the separation of the fairing. The DDO has called out right on time. You see there's one half on the left, the other half is falling out of camera range on the right this time. We can separate the fairing now because we're out of the dense layers of the atmosphere. We're over 100 kilometers up, as you can see on the bottom left of your screen. Neither friction nor heating, which could disturb the passenger, so we can get rid of the dead weight. We are into the second powered flight phase. The boosters have done their job. Only the single lower stage engine burning now. It'll burn for 9 minutes roughly. Our speed is important. That's the role of the main stage. Its cryogenic propellant is not only highly efficient, but provides a push that can last for a long time. There are different propulsion systems you have noticed on the Ariane 5. Cryogenics, as used in the main stage, are more efficient than solid propellant, which is used in the boosters. Basically, and I'm no engineer, but I do know that solids are for getting us off the ground and away from the pull of the Earth, while cryogenics are more for precision orienting of a vehicle, and we'll see that later on with the upper stage. And of course, they allow the upper stage to be ignited in this version of the Ariane 5. Ariane 5, remember, is the heavy lift launcher. The 2 other members of the family, Soyuz, lifting middle-sized payloads, 2 and 3 tons, and Vega, the light lift vehicle for missions of 1 ton and under. Shot of the downrange tracking station.
Acquisition de la télémesure lanceur par la station navale Ariane.
Galileo in yellow is the station here, the tracking station in French Guiana. And you see the point of light where Ariane is right now. We're going to the first of what we hope will be several replay shots of liftoff that happened 6 minutes ago. You can relive those intense moments as Ariane 5 took off from the pad. We have cameras at several of the half-dozen observation sites that are stationed across the base, and they furnish us with shots from different angles. And here's another one from a little further back. We should have even more footage later on. The closest observation site is called Toucan. Some of you may have been out there. Many of the VIPs are there tonight, including Patrizia Secchi of ESA, who is going to be joining us here in the booth during the second part of the broadcast. We have been picked up by our downrange tracking station, the ship SNA, the Station Navale Atlantique. That's a ship designed specifically for Ariane missions. We have ground stations, but we also have this boat which can move around to follow the launchers, picking up its radar and telemetry signals. All of Ariane's trajectory, of course, being designed to be followed from the ground. The launcher is sending radar and telemetry constantly back down, and a network of these stations are keeping a constant watch on the health of her systems. Telemetry, you may be asking, what is it? We hear this word a lot. Well, telemetry is launch vehicle data, simply. Information on thousands, I would say 1,500 parameters, is being collected and transmitted to the ground stations every second by the two transmitters on board and the antennas outside. These include indicators of Ariane's health and performance in flight.
La trajectoire est nominale, tous les paramètres à bord sont normaux.
Everything is perfect on board, says the DDO. On the left is the flame of the core stage engine still burning, and the long gray tube, that's the lower stage, sorry. Above that, a white band is the upper stage, and you see the 4 satellites exposed to the elements now with their blue solar panels. They're exposed to the elements with the separation of the fairing. The telemetry which comes in is analyzed in real time. Customers get immediate information about their spacecraft, very important for them. Other data are analyzed after
Il reste moins de
the
30
flight
secondes de poussée de l'EPC.
to learn how the vehicle has performed. About 30 seconds left in the first stage burn, and you'll hear the DDO, and you'll see on the screen, the DDO will call out extinction, and you'll see the blue flame in our animation go out, and then the lower stage will be separated, and then watch out for the ignition of the upper stage. All that coming up. There's the
Extinction de l'EPC sur commande de guidage.
confirmation by the DDO.
Séparation EPC.
Of the second stage, and we're waiting for ignition of the upper stage. There we go.
Allumage de l'EPS.
All confirmed by the DDO. These 3 orders given by the onboard computer in about 13 seconds. The separation, the lower stage after separation falls into the Pacific off the coast of
Tous les paramètres à
Peru.
bord sont normaux.
We're now in the 3rd powered flight phase. This is a first 11-minute burn for the upper stage. It'll burn until plus 19 minutes and 55 seconds. There will be another in the second part of the broadcast, about a 6-minute burn. With separation of the lower stage, Ariane 5 has used up all of its 175 tons of propellant, and she has now lost about 14,000 kilos of dry mass. Remember, we were originally 760 tons. All that's left of the composite are the 3 satellites, the upper stage, and the vehicle equipment bay. This is the 54th mission for ESA by Arianespace, and there are more in the launch manifest. 3 for the European Commission, carrying 9 spacecraft, 8 Galileo and 1 Sentinel-2B, as well as 4 other missions. A lot of ESA missions, EDRSC, that's part of the European Data Relay System.